Alright, welcome to part 2 of the video. This is how we already created the 1000 amp shunt. We're running the 24 volt system here. These are 2 charge controllers here. Okay, all in all is 3 charge controllers. And I had a temporal wire I have around here, which is going to be for another charge controller. Just like I said, it's a test. It's a small wire till we get that. So I'm going to clip that one. I'm going to clip it in the center or whatever. It's going to be here. And this is the battery side. This is one charge controller, the Victron. So this is the Midnight Classic 150. Then the other one's going to be like this. So like I said, it's a temporal fix. Because if I want to do this, I have to beef up these bus bars. So I have to change the bolts. I have to find some long bolts that are going to penetrate whatever is an inch or half inch thick, and trying to set them up here and created a bus or whatever. Or we can take this entire thing and take these wires here to a bus bar and we tie the loads there. There are different options. So I don't want you to be arguing about something, or maybe give some criticism about something. This is science. We're testing things and it's gonna work. I know that. So let's go back to work. Now I'm gonna be taking the power from that's supposed to power the shunts right here, the Victron, and got alligator clip and clip it to this guy here. Okay, you can see a little surge or arc. Okay, and this is evening time. We don't have no solar. That's why I decided to do this. And the purple wire for Midnight Solar or Whizbang Junior, always the purple going to be pointing to the battery side, which is here, which is a 500 amp hours. Here is a 50 millivolts, both here. All right. If you look at this one closely, I don't think you see it's probably flashing right now. And we're gonna go ahead and hook this other guy here. Another charge controller. And like I said, we are not having any sun. This is the evening time, so don't worry about anything might happen, because we're gonna test that, see in the morning if everything works. Then we can make part 3 of the video. So now what we do, we have a disconnect here for the charge controller. I have a disconnect here for the Classic. And I have this guy, which is a Nissan Leaf. A quick disconnect is very, very safe. There we go. All back fired up. Found one device. And now we're gonna go back here and turn this is the battery side. And it powers up. And let's bring this guy here. It's already powered up. And this guy, we're gonna power this one up. So both of them up. So we have that guy right there up. And this one, the inverter is on. And what I'm gonna do, we're gonna turn the app, the phone or tablets, to see what is going on here. There we are. It's up. So right now the shunt is right here. and it's gonna be like thinking. It doesn't have a full calibration yet for 100%. See that? So what I've done, I already went back and linked them together. See, I have the two charge controllers linked or sync together, the shunt. So you can see them here. They have the check mark. Anytime you see this, so it's already linked. And there's a name for it. Volkswagen e-Golf 24 volt center. That's the name for the device. Here, this is the 70 amp hour charge controller, and here is the 85. So if we go back here and try to see the shunt up, and I'm going to show you the Whizbang Junior. Wi-Fi system's not too good with this stuff. So this is what it is. So you see it's reading -8 because it's pulling power, which is -0.25 amp hours because of the charge controller, and the inverters are all on a standby. So when you're running applications like this, you always have the soft key right here. You gotta punch it like 2-3 times, and it shows that we have 430 amp hours total, which we have 150 amp hours total. So right now it's pulling 0.3 or 0.2 amps from the battery on a standby. So I don't know if we're gonna able to initialize, because the batteries are still charged, and see we can put a chart on the grid on and see if we're gonna be able to charge this battery and see the amps and can make a comparison. So right now what you're seeing, I forced the system to try to charge the battery, which is they are full, but it's like, okay, 200 watts coming, 5, 8, a kilowatt. So let's see what the shunt is reading. Well, this is what is going on right now. So it's about a kilowatt, and I'm seeing about 13 amps going. I think it's going on each shunt, and 420, almost 424. So let's check the Whizbang Junior. Here goes the Whizbang Junior. You guys can see 13.5 amps, 13.6, and state of charge is 75 amp hours. We have about 12. The net amp to replace is a 12. So 13.7. I think we're just sharing the power to each shunt. Let's go back and check the Victron Smart Shunts. So 13.5, remember that number. So 13.5, 13.5 almost, yeah, it's going there. So that means it's sharing the power. So what we're trying to achieve here, I don't know if this guy is going to be able to calibrate to be 100%. I think I have it probably in series. It's supposed to be in a parallel. So by doing so, it's sharing, each shunt is reading its own amps that pass through. So I think what I have to do here, like I said, is a science project. I think this is the battery side. I think what I have to do, I have to take this shunt, each one I want to, whatever. I can take this one here, will be on the back side of this guy right here, and we take the load side and connect to this guy here, the battery side, and this is going to be like the